All right. So yeah, so we're going to finish up a little bit of the simple linear regression activity that we had left from last time. I want to note that it's been a while since we had a homework, but we have a new homework now posted on simple linear regression. Uh, it's on a data set on Olivia Rodrigo's songs. So does anyone like Olivia Rodrigo in here? Yeah, cool. That's good. I'm too old now at 30 to like, I didn't know who Olivia Rodrigo was. I deep dived into it, tried to pick out someone that would maybe be more popular um, for you all. Who would be in like, who's another like popular artist that you all like right now besides her? I mean, Taylor Swift. Yeah. Okay. Well, that's great. The SAS activity we're going to do today is like the same, but it's like Taylor Swift videos. So, but I like Taylor Swift. That was like she was cool when I was in high school. She's been around a while. So, um, yeah, is there anybody else? Or is it it's just Olivia Rodrigo and Taylor Swift? Oh yeah, Harry Styles. Okay, yeah, that's what Lauren, uh, my fiance Lauren teaches Stat 215. She said that yeah, Harry Styles is another popular. That makes sense. Also was popular when I was in high school, but that was like One Direction. Yeah, so it wasn't as cool then. But I think he's gotten cooler now, which is kind of funny. But okay, yeah, Harry Styles. All right. Well, thanks for helping me keep up on the times here. Um, okay, so we're gonna finish up simple linear regression today. So let's see where we left off. Okay, so we were looking at um, an equally exciting data set on Scrabble letters and their point values, and how that relates to, see if we can scroll up, like how easy that letter is to play in Scrabble. So we have this measure of the percent um, relative frequency in English writing. So the idea is that a letter that occurs more is going to be easier to play in Scrabble. So it should be worth less. We would think that's how people design Scrabble. And conversely, a letter that occurs less often in English writing is harder to play, more difficult to play, so it should be worth more, right? So we were looking at how we have these two quantitative variables and the Scrabble tile point value, how often that letter occurs in English writing, and we can use a simple linear regression to relate the two variables. Maybe if we were designing a Scrabble game, like Scrabble didn't exist, but we were designing this game, we could use this information to help us decide what the point values are, maybe. Or if we wanted to make Scrabble, let's say for like a different language that has different characters, we could use this data set to help us inform how we would do that. So yeah, we gave a statement of our estimated model, or our theoretical or assumed linear regression model, and then we were asked down here to give a statement of our estimated model. So let's, yeah, okay. I gave an example right here. So let's copy this as like our blueprint starting point, and then we're going to paste that below. All right. Okay, so unlike the theoretical model, we do want to change the equation a little bit. So the thing is with the theoretical model, which we gave right here, we don't know the true value of beta naught and beta 1. So we keep it general in the equation when we give it here. But for the estimated equation, if we have regression output from the model fit, we do have like the numerical estimates for the betas. Okay, so we'll include those in the equation. So let's start with the estimated intercept. Okay, so we talked about it right up here, but I'll show. Let's look again at the SAS output where we grabbed that from. Oh, it's actually below. Okay, so I'll zoom in even a little bit more so that maybe it's for those watching in the video. Okay, so the regression output, this other stuff is exploratory data analysis, like from ProcCore, looking at the correlations of variables in the data set. This is just printing the data set. This was a scatter plot made with ProcSGplot. Okay, the output that is specifically from fitting the linear regression model starts with a title in SAS called the GLM procedure, which stands for, I'll write this out. GLM stands for generalized linear model. Okay, if you go on more into statistics, you'll see this pop up again. It's a very widely used class of models. The linear regression model and the simple linear regression model is one specific case of a GLM, but there are many other GLMs that are widely used. Has anyone heard of logistic regression before? Yeah, so logistic regression is when you want to predict a binary outcome, but you can also view as like a categorical variable as your outcome. So like, are the Lions going to win the Super Bowl next year or not? We can get an estimated probability of that using a logistic regression model. That's a case of another GLM. For linear regression here, we're predicting a quantitative response variable. So that is that. And not to be confused, I remember in grad school, one of my professors used these interchangeably, but they are not interchangeable. There's also general linear models. They really need to get a little more creative with the naming and statistics, but these are not exactly the same thing. So linear regression models are cases of general linear models, which all general linear models are GLMs. So it's kind of like how do I even have a symbol like that? Well, these fall under the umbrella. General linear models fall under the umbrella of GLMs, but they're not the same thing if you hear those two terms. Anyways, okay, so here's the regression output, and gives you a lot of things. Does this look familiar, this table here? Yeah, so what is this right here? What do we call this? This table. It's an ANOVA table. Yeah, so every regression model has a corresponding ANOVA table. Right, that somewhat has to do with the fact that ANOVA is actually a specific case of regression. So a lot of the concepts from ANOVA carry over to regression. You can interpret these in similar ways. We'll talk about that a little more later, but not in this activity. For the regression estimates, we're going to look at this table right here. Okay, so the easy way to identify it in the SAS output, because it gives you so many tables, is this is the one that has a column that says parameter. And none of the other tables in the GLM output have a column that says parameter. So that's how we know it's for the regression estimates. It gives you the estimated intercept, and then it'll say the name of your predictor variable, your X variable, right next to the estimated slope, beta hat 1. Okay. All right, so the estimated intercept is 5.64, and then minus 0.59 for the slope. So if we go back, oh, I do. So 5 minutes. So that's how we can give our estimated regression equation. And then we would just, down here you can say, like you would update these values. So you update those numbers, update these values. And then what else should we update in how we're describing our model here? Right, the definition of y hats and x here. So y hat in this case is the predicted, and then instead of saying response value, we can say, describable tile point value. Or the letter. And then notice that, so this is one of the most common mistakes in the estimated regression equation is putting a hat on the x. Okay, so x and, like the estimated equation. Yeah. So you can either, like, I copied this actually from the top of this activity, but in the guide, should be in there as well. So so under linear regression, simple linear regression, that section, right here. Yeah, and I don't give the beta hat and beta 1 in the bullets below it here. I've seen it both ways, and I think it's fine both ways, because if you give the values in the equation itself, it's sort of implied. So you can also define them like we're doing here in these two bullets, but if you just do y hat, that's okay too. Yeah. And so x, so that's one of the most common mistakes is accidentally putting a hat on the x, but we consider it constant. Like we're considering that x is known and we're just trying to predict y to estimate y. So that's why y gets the hat, the x does not. The other most common mistake is that note that there's no residual or error term in the estimated regression equation. So it's just as is right here. Whereas the theoretical model has the epsilon error term. So that's not on the estimated regression equation. And that has to do with because like if we have the scatter plot, and then we have x, and we have y, okay, and then we have the data points. And then our line of best fit. Okay. In the assumed regression model, we have y on the left-hand side, and y is the points themselves. There's the height on the scatter plot of the points themselves. And so there's some error compared to the true line of best fit, where the points fall above or actually below the straight line of fit, so that epsilons capture that variation there, how the points don't fall exactly in a straight line pattern. But in the estimated equation, we're talking about y hat, and all of the y hats fall exactly on the straight line of best fit. So that's why they don't have a residual or error term. questions about that? Yeah, like I said, those are the two most common mistakes. So hopefully, um, that's cleared up. Okay, and yeah, so X is in this case, the percent relative frequency of a letter in English writing. And then lastly, we'll get a predicted value. Okay, so we'll use our estimated regression equation to do this. I would always suggest writing it out like this when getting a predicted value and then filling in, and then filling in the values. You can sort of jump right into it, but I think it helps you stay organized for one thing, and for another thing, if you show your work, you can get partial credit even if you end up making a mistake. But and this doesn't happen very often, but I've seen the case where I ask for a predicted value on like an exam, and then I just get one number that's wrong, and so you can't get partial credit. So there's no like work shown for how that was calculated. But if you show your work and it's just an arithmetic mistake, I'll probably give you like nearly all the points if it was just adding two numbers wrong, but you had the right equation. So here, what is the expected Scrabble tile point value for a letter with a relative frequency of 5? So what should I change in my equation to calculate this predicted value? Right, yeah, we change X to be 5. Okay. And then we can use Google or a calculator. I think I mentioned this before. It's tempting, or I've seen students want to like make this a whole number because like Scrabble is only, Scrabble doesn't give decimal point values to letters ever. We know it's always a whole number. But when you're giving a predicted value, the idea is that you're giving your best guess. And so if you round up to 3 when the model tells us it should be like 2.7 here, your error is going to be a little bit larger in the long run. So the idea is you keep it as a decimal, even if it doesn't make sense for the context. Kind of like if I was predicting how much the Los Angeles Lakers would beat the Detroit Pistons by in a basketball game. Like, yeah, they cannot win by a decimal of a point, but if I keep my prediction as a decimal, it'll be more accurate or like closer to what the actual value was than if I round every time, even though you have to score full points in basketball. Any questions about that? Okay. Then that's the last part of the activity. Let me make sure and double check that. Yeah. Okay. So any questions on the activity as a whole before we move on to a SAS activity? Okay. So make sure to submit that via Blackboard under assignments activities. And then there was this activity 6. And yeah, we'll get started on a SAS activity then. SAS activity 5. Like I said, the homework's on Olivia Rodrigo songs. This one's on Taylor Swift. kind of made this one first because I like Taylor Swift, but then I was like, oh, okay, maybe that's dated now, so I tried to make something you all would like more, maybe. So I scraped this data from YouTube using R, actually another programming language. But we have data on all of so Taylor Swift has a YouTube channel, right? You can get the number of views for each video, the number of likes for each video, the number of dislikes, and the number of comments. I actually scraped this it was less than a week before YouTube disabled the dislikes. So this is kind of unique because you can't get this data anymore unless you're like on Taylor Swift's team. They can see that data, but it's not available to the public anymore. So we have one of the last known measures of how much her videos were disliked. And same with the Olivia Rodrigo data. So the idea is we have all these variables and we expect them to be related to each other, right? If a video is viewed more, we'd probably expect it to have more likes and more comments, also probably more dislikes. But let's use linear regression to see what's the relationship between these variables. Okay. So let's get SAS Studio open and we'll start by importing the data. All right, so we'll save a new program. So I'm doing save things. SAS activity 5. Yep. So remember, we have to save when we're done today because SAS Studio does not save automatically. So make sure you save your file before you leave. So let's start by importing that Taylor Swift data. So that should be under my shared file links. This alphabetically sorted. It's called Taylor Videos. So remember, there's a few ways you can import the data. I'm using the import wizard. I right-clicked on it and then clicked import data. And then I'm gonna essentially had SAS kind of write some code for me. I like to do it this way because then it automatically creates the file path based on what I clicked on here. And if you do that too, then it will tailor the file path specifically for your SAS session, which is nice. And then we want to change a couple things always when we import the data. Generally, does anyone remember which options we like to add? Yeah, we changed the name of this, so we can call it yeah, I said to call it Taylor videos. So by default, it just calls it import, but we're going to call it Taylor videos. What else do we usually update in the code? I know it's been a bit. So we usually add guessing rows equals max, which, as a reminder, that tells SAS, I think it by default looks at like the first 30 rows or observations of the data to guess what types the variable should be, which again has to do with SAS's age. But nowadays, like, computers are fast enough, we can just tell it, like, you should look at the whole data set to decide what the type of the variables are. Because it's so fast that we don't notice a difference either way. So, and then after ref file, we'll also add this option replace, which tells SAS to replace any SAS data set that's already existing that's called Taylor videos, if one does exist. This is only helpful if, like, the CSV file here got updated for some reason in the middle of us working on the program, but it's not likely, but it's usually what we would want to happen. Okay. So we update the data set as we import it. Okay. So after you import it, it should look something like this. I'll go back to the code and we'll make sure we're all through the import step before we move on. Yeah. Yeah. Any other errors with importing the data? Cool. I need that anymore. So yeah, this is kind of a cool data set. Again, I got this via the YouTube API. It's called, like, you can ask for data about publicly available YouTube videos. So each row is for a single video on Taylor Swift's YouTube channel. So we have its number of views, the number of people who liked it at the time that I scraped it, of course, the number of dislikes. It has this variable favorite count, which was always 0 for everything. So that's, I don't know why that's included. It's not meaningful, right? But we have the number of comments. This is like Taylor or YouTube playlist ID, which we probably don't care about. So the name of the video, which is interesting. That's useful. Yeah, it gives us exactly when the video was published, and then the playlist name. Okay. So yeah, so we've got that imported. So that was 1A. Now for 1B, we're going to get summary statistics for using proc core. So always good to, when you're first getting acquainted with a data set, like, it's good to just make some visualizations to look at the data, get some summary statistics, sort of get acquainted with it before you jump right into fitting a regression model. It's not often the case that you'll import the data and it's like exactly in a format that's ready to go. I mean, this one is because I got it ready for class, but usually you have some other things you need to take care of first before you can jump right into fitting a model. So yeah, so proc, we use proc core data equals, oh, and then did I say to print the first 10 rows? Did I skip that part? Oh yeah, I did. Okay, sorry. We're supposed to print the first 10 rows for part A as well. So, um, so get rid of them. Does anyone remember what the name of the proc is that we use to do that? Proc print, yeah. And then we have to put the data set name, so it has to match what we had in the out statement here. And this will print the whole data set by default, but we're just going to look, because it's kind of a big data set, we're just going to look at the first 10 observations. And we were already looking at it in the viewer, but this like creates output that will be, in our whole output report at the end. So it should look something like that. Then we can use proc core. So proc core, you can specify which variables you want. If you just want a subset of the quantitative variables in the data set, you can do that by using a var statement. If you don't specify the var statement, SAS just assumes you want correlations for all quantitative variables in the data set, which is what we want here. So we'll do that. Okay. Yeah, so it gives you, it's nice. It gives you like these simple statistics. It calls it, these we could have gotten with a separate call to like proc means. SAS is really, in general, tries to give you like more than you could possibly want when you run things. So here's just some summary statistics: the average number of views for a video, yeah, average number of likes, the minimum and maximum. Apparently, one video has no comments. That's kind of strange. Maybe they disabled comments for it. That would be my guess. I really doubt that that's possible. And then how many videos are included in this data set? 133. Yep. So decently big. So yeah, that's just some summary statistics. Here's the table of correlations, which as a reminder, how this works is like they give this in what's called a matrix. Matrix is like a table of numbers. And for the correlations, it's like you can look at the bottom triangle of the correlation matrix, this is called. Oops. And that gives you all the correlations for the data set. Because actually, if you like took this bottom triangle and the top half triangle, they're exactly the same, just mirrored over each other. So you really only have to look at the bottom one. And that gives us, for example, the correlation between the like count and the view count here, correlation between the dislikes and views, comments and views. Okay. And then the correlation of a variable with itself, which is given by the diagonal entries, is always 1 for every data set all the time. Okay. And then you'll notice it gives the correlation and then there's a number below it, right? So this is a p-value for testing if the true correlation coefficient is 0 or not between the two variables. We're not getting into testing of correlation coefficients because it's equivalent to the results of testing the slope being 0 or not, and we're going to talk about that. But sometimes people, you might see that in like a research paper, they test, is the correlation 0 between these two variables or not? And there's a t-test you can do to do that. So that's what this is about here. The data set's so big and the correlations are so far from 0 that it's not surprising that the p-values are all super small. All right. So let's see, what did we ask? Oh, we didn't ask anything more about it. Well, so which two variables have the strongest correlation in this data set? Yeah, it looks like, yeah, comments, right? Comments and likes. It's about 0.98, which is really strong. Correlations are bounded between -1 and 1. But the correlation only tells one story. Like if you remember back to the activity we just looked at, had this cautionary tale about how a correlation tells one story, but you need to plot the data to see like what's actually going on in the data set. And so that's the case here as well. You really only can rely on the correlation if it seems like it's a straight line pattern or relationship in the data. Otherwise, you can have very different patterns, but still have a strong correlation value. So let's see for this data by, let's plot this. Oh. Oh, wait, I guess before we do a scatter plot, I ask for a visualization showing the number of videos for each album. Is that what I did next? Okay, yeah, I guess in part D we make the scatter plot. So in part C, we will make a different visualization. So if we want to show, yeah, let me run procprint to look at our variables again. Okay, so we've got the album, which is given by the variable playlist name. And then each row is for a video. What kind of visualization could we make to show the number of videos in each album or each playlist? Bar charts, yeah. Anytime you want to show, essentially we're visualizing a categorical variable. If you want to show the number of observations in each category, the bar chart is a good bet. You could also use a pie chart here, but we talked about why those are not ideal. So we're going to use a bar chart. So proc is gplot. Oops. To make a bar chart, we can either make a horizontal bar chart or a vertical bar chart. For a vertical bar chart, we use V-bar. And you say the name of the variable that you want. Or actually, let's make a. Did I say horizontal bar chart? No, I didn't say, but we'll make a horizontal bar chart here because there's so many albums. And then we say the name of the variable, the categorical variable, which you can get by. It's usually a safe bet to copy it from like the output from proc print just to make sure it's spelled correctly. And that will give us a plot to look at here without any labels updated or anything, but we'll just start by looking at that. Oh, maybe something's wrong. Oh, H bar. I don't think I need the equals there. No, yeah, no equals, sorry. There we go. So there's our bar chart. Yeah, this was scraped in 2021, I think. So yeah, we're missing a couple albums. Evermore and Midnights. And so when you have a bar chart, so we could have done a vertical bar chart. The thing is, sometimes when you have a lot of categories, in this case, it's not too big a deal, but sometimes when you have a large number of categories, it's better to do a horizontal bar chart. It makes it easier to read the names of the groups going from top to bottom. But in this case, it's not too different either way. We'll use the horizontal bar chart though. And then, let's see. Okay, yeah. Anytime you have a categorical variable with a bar chart, if it's ordinal, you should sort by the categories based on that ordering of the variable because SAS won't know what that ordering is. So for example, if we had freshman, sophomore, junior, senior was the 4 categories, we should have them in that order on the bar chart. And so we could use code to do that. If it's not an ordinal variable, so if it's nominal, you should sort the bars based on their height. So you can do that by adding this slash category order option. Say category order equals RESPDES for response descending. And it sorts the bars based on height. So that's good to do because if you have this kind of plot, again, the point of a data visualization is to communicate what's going on in the data very quickly and efficiently. And so this allows us to more quickly see like, okay, folklore has the most videos, Fearless has the least videos. Whereas before when they were all jumbled up, you have to kind of look more carefully to figure out which exactly was the shortest. Looks like there's a tie actually between 1989 and Fearless here. But, all right, and then yeah, we can add. We always want to add labels. So a title. So we'll say like something like these are all these playlists are just the albums, Taylor's albums. So we'll just say videos by album. Okay, and then we can do that. Make sure you have a semicolon at the end of the title statement. I think it doesn't look blue if you accidentally forget it. Oh, the coloring gets messed up below, I guess. I want to make sure we have that. And then, okay, so fix the title. And then you'll notice here it says playlist name in like camel case. We could probably update this to say album instead. So we can do that by using a y-axis statement saying label equals album. Okay. So then it should say album over there like that. Any trouble with the bar chart at all? All right. Then part D is creating the scatter plot. So we will do that. Okay, so let's use practice gplot. All right, and then to make a scatter plot, we use the scatter statement. So scatter, and then we have to specify x, our predictor variable, and y, our response variable. So here, this is a case where it's like sort of interchangeable. You could, I guess I could see the argument either way, like which one predicts the other? Likes predicting dislikes or dislikes predicting likes? Yeah, sort of interchangeable, and that's okay. We can still use linear regression. Here we'll just say x is dislikes, and we'll say y is likes. or it's like dislike count, I guess is the variable. And then y is like count. Right. This again, without the labels updated, we can just take a look at it already. See how that looks. I guess before we even look at it, do we expect this to be positive relationship or negative relationship? Yeah, positive, right? Based on the correlations that we looked at. Also just thinking about it, right? Even though these are kind of like opposite things, likes and dislikes, if the likes go up in a video, what does that likely correspond to? It's getting more attention, yeah. So when the video gets more attention, it's probably going to get more dislikes too. And so, yeah, we can see that that looks to be the case, although there's some interesting patterns going on. But generally, it's like this increasing trend. It's not super linear, though, is it? There's some weirdness going on. So if we look at the code, so one thing, sometimes when you see something unexpected, it can mean you need to control for the effect of other variables. Okay. In this case, maybe it's important to look at this relationship within the albums, within each playlist. Okay, so we can say, we can color the points based on the playlist by adding a slash and then saying group equals playlist name. And yeah, that should color based on the playlist, color the points based on the playlist it's from. Yeah. So if we look within a playlist, does it seem like it's more linear? Yeah. And so sometimes that can happen. It's a little tricky because you don't even always know what the extra variable is, or it might not be something that you even have recorded in the data, which is, yeah, that's an extra difficult case. But right, yeah, that's the reality of data analysis. So yeah, we can see, like, for example, folklore. Folklore seems to be getting many more likes, and then it's also getting slightly more dislikes, maybe. So everything all together, it's getting more attention. At least when this data was scraped, might look different now. Right? So let's update the labels so we can do the title again. So we'll say likes by dislikes. Oops. And then if we want to update the X and Y axis titles or labels, because it just says like dislike count using camel case here, we can like make this look a little nicer. So we can say Y-axis label equals that, X-axis label equals that. Okay. And then X is the dislikes, number of dislikes, and Y is the, wait. Oh, I have that wrong. X is the number of dislikes, Y is the number of likes. Make sure each of those get their own semicolon. I've had people ask before, like, why do we go through all this trouble? It seems so much more difficult than using like just Excel to make like this type of plot. And yeah, for sure. Like if your only goal was to make a scatter plot for this data set and just that's it, it probably would be easier to just do that in Excel. The benefit of like using SAS like this or any other programming language is that it's more um, reproducible, we would say. Like someone can see you started with the data set unaltered. They could take your code and run it and get your same exact results. But that's a little bit more difficult to do with Excel. Like Excel, you would have to like describe all the buttons you clicked, and so it's not as reproducible. Like other people can't get to the same results you did as easily, especially as your analysis gets more and more complicated. Like if you're fitting a model and making some visualizations and doing this and that. That's where the benefit of coding rather than using something clickable like Excel really ends up paying off. Right. Yeah, so let's see how that looks. So now the axis labels look nice. The title looks nice. And then the only thing is this part where it says like playlist name in camel case. Like, we kind of want that to say album. Okay. So we can update that as well. And we do that with a statement that says key legend. Like that part of the plot is called the legend that's telling us which albums correspond to which colors. So we say key legend slash title equals album. Yeah. 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 Yeah, now that plot looks good. So yeah, very different relationships within each album. Which is kind of interesting. Like if we think about the steepness of the line of best fit within each group, like maybe here's the one for folklore, but then it looks like for what's this like salmon one 1989. 1989 maybe looks more like this. So what does that mean since the slopes of the lines were quite different? Right, it implies, yeah, maybe different correlations within each group. And then like practically speaking, what does that mean for the albums, like in terms of how engagement is going on in the videos? Yeah, the 1989 one is getting slightly more negative reactions maybe. Um, at least like the ratio of likes to dislikes is higher for folklore. So you're getting more people liking it. People are liking it at a higher rate compared to dislikes than for the 1989 album. And considering I scraped this in 2021, does anybody know why that might be the case? People don't like that video. Yeah, maybe. So I was kind of surprised to see this because I wouldn't say like that folklore is considered like this super popular album in the grand like scheme of Taylor Swift stuff. So why is it showing up in the data like that's the case? Yeah. Mm-hmm. Yeah. Right. Yeah. This was one of the for sure. This was one of the albums that was released like during like quarantine time. So it's getting a lot of engagement then, and it was very recent. So this is like a recently released album. And like when you think about like when she first like drops things on YouTube, who's gonna be like right on it the day of engaging with it the most? Like super Swifties, yeah, right? Like fans who are much more positive about it. And then maybe over time, it's like you get the more general population interacting with the video. So that's like important to note here because if you don't like consider the context, you might think like, okay, yeah, folklore is way better than the other albums, but it like has to do with when this was scraped and when the album was released on YouTube. Like there's some complicated factors going on, right? Yeah, I wonder how I was thinking about like how like if you're on Taylor Swift's team, how you would evaluate like which albums seem to be doing better than others. It seems like a tough task since they were not released at the same time. It's kind of hard to compare, but yeah. Okay. So yeah, we made that plot. So ideally, we would probably fit a separate model within each album, okay, which can also be done using like a more complicated model like multiple linear regression. You can actually include the album as a predictor. You can have categorical variables as predictors in the model. That would be ideal. Since we're only on simple linear regression here, we're sort of going to ignore that we saw that and just fit the whole data set in one simple linear regression model. But yeah, ideally you would explicitly control for the album. I think this will be the last thing that we do today. So to fit a linear regression model in SAS, we'll use proc GLM. Oop, GLM. Okay. And then we need to say, we specify what our model is. So we say model. And then the general format is response variable equals predictor variable. But we need to have the actual variable names from the data set. So in this case, we want to predict the number of comments a video will get using its number of views. Okay, so if we look at like the variable names, it's comment count and then view count. So which one should go on the left, and which one should go on the right? Right, yeah. And then view count. And that's it. This fits a simple linear regression model in SAS. So to get those results, it gives you the line of best fit. Okay. Here's our regression estimates. Okay. And we also said to get diagnostic plots, so plots to help us check the model assumptions. You can do that by adding this option, plots equals diagnostics. And then SAS will give us that 3x3 grid of diagnostic plots to check. All right, so there's our diagnostic plots. Let's see what this. Oh, okay, yeah, just the code for 2. Anybody have any issues with that code? Okay. And I guess we'll do 2B. We'll get the regression estimates. So we have beta 0 hat and beta 1 hat. Okay. And I'm not going to write these down here. I'm not going to type it, but we'll talk about it. Because I want to make sure you know where to get that from the output. But I want you to put the number here actually in your SAS document. So what, based on the output here, what are the estimated intercept and slope? Yep. Yeah, so we were looking for, this table with the parameter column. So this is our estimated intercept, and then what's our estimated slope? Yeah, the number right below it. Mm-hmm. So this is beta hat 0, and this is beta hat 1. Okay. Make sure to type those in the code to get those values here. Okay. If we look at the plot, okay, the scatter plot here, SAS is actually giving this this is like scientific notation. So 2E7. Does anyone know what that means? It's okay if you don't. Yeah, 2 times 10 to the 7th power, which is like, what is 10 to the, I think 10 to the 6th power. Right, yeah. So 10 to the 6th power is 1 million. So 10 to the 7th is 10 million. So this is, yeah, like 20 million, 40 million, 60 million. Yeah. Lots and lots of views. Yeah. So the intercept's super negative here. Yeah, couple issues with that. So sort of ignoring the context of the problem, that would kind of be telling us that if a video has 0 views, we would expect it to have this many comments. Doesn't make sense, right? So yeah, a couple of reasons why. One is that there's no video in this data set that has 0 views. So that's like, these are really close because of the scale, but there's no video that only has 0 views. So that's outside the range of our X variable. So that's called extrapolation to interpret what that would be, to interpret that value. So that's one reason why it doesn't make sense to interpret the intercept for this problem, because 0 is outside the scope of our X variable. The other is just like the practicalness of the problem. Like, is it possible for a video to have comments if it has no views? I don't think so. I guess I'm not sure. Maybe you can like open up the video, not view it, but comment on it. It seems like it doesn't make much sense. So yeah, a couple strikes against interpreting the intercept here. So here you would just say like, it's not appropriate to interpret the intercept in this context. The slope makes sense though. We can interpret that. Okay, we'll talk about that more next time. So that's where we'll leave off. Make sure you save your SAS script before you close out. And yeah, we'll pick up with this activity next time.